Cardiac pressure graph should be studied in tandem with the processes involved in the heart, mainly the ventricular contraction, relaxation, then the atrium relaxation and the atrium contraction. To be able to understand this graph, you must be very familiar with the heart structure, the valves involved, the left and right side of the heart. So assuming so, let's begin to explain the graph quickly. Alright. I've labeled the graphs in the different colors as much as I can. If you can, you can draw this one out and try to explain it. Okay, so whichever level you are using this, we always have problem with this. So please take some time to pause here and listen again. The pressure graph always have the pressure is actually talking about pressure in the chamber. Always talks about the force of the blood hitting on the walls of a chamber. By means of the chamber, I'm talking about either the atrium or the ventricle. So beginning of the graph, you will see a very important idea here is that when the pressure of one chamber is higher than the one below, you will force the valve in between them to open. For example, when you have a chamber like you have like this, and this is the LA, this is the LV, the pressure here must be very high. Then it's able to force open this valve here for the blood to actually flow inside. Okay, to the left ventricle. With such an important idea in mind, you can start explaining now, right? At the beginning, the left atrium, as you can see here, we're looking at this part here. The left atrium is actually have a higher pressure compared to the ventricular systole. So for this whole period of time here that we are looking at, alright, we actually take note that for the left hand side, it's called the bicuspid valve between the two of them. So this one, the bicuspid valve, open throughout, okay? So what happens is that the left atrium is contracting and pumping blood into the LA, contract, pump blood into the LV. Okay, until you reach a point whereby the pressure of the LV is higher than the LA, so the bicuspid valve can no longer be open. So at this part here, the bicuspid valve will close. Alright, so this is the first point when it closes. Alright, as the blood continues, okay, to stay within the ventricles, the left ventricle, the pressure will slowly increase. And what happens now, since it's the left side of the heart, after the LV, the blood is supposed to go around the whole body via the aorta. So relevant to talk about the aorta pressure now. When the left ventricle pressure is higher than the aorta at this point, it will open up what? Open or close? Open or closed? Opens semi-lunar valves in aorta. Alright, because now the blood is being pumped, contract and pumped from the ventricular LV into the aorta. It will continue to do so as it goes up. You can see because here the blood is filling, what is being pumped from the LV goes into the aorta. So there's a similar trend. It continues all the way here. Okay, all the way here. Sometimes you see for this part of the graph, it's either a little bit higher, but you don't have to worry about it, or there is an intersection that actually occurs here. Not this part, So here, when the aortic pressure finally is higher than that of the left ventricle for this one, we say that the semilunar valves in the aorta closes. Right? It has actually already closed. Alright, so what happened is that because all the blood in the left ventricle has been pumped into the aorta, and then this one is going for the rest of the body cells. Am I right? Right, and this is actually your systemic circulation. Can you see it? In case you don't realize it, for the pressure graph, you do not actually are able to see the pulmonary circulation in action here. Alright, so as the left ventricle pressure continues to decrease, it will drop lower than the left atrium, and what happens now is again same thing, the bicuspid valve opens. Okay, so generally, if you look carefully at this cardiac pressure graph, we are only focusing a lot on the closing and opening of the valves, as well as the pressure differences when the blood is changing from one chamber to the next. You still need to remember the exact cycle, exact words we actually use, such as systole, which means contraction, alright, and diastole, which means relaxation. The proximate graphs is actually like this. Some graphs have slight differences, but the points where we are looking at is usually there. Take note that this point is never the point where you mark. Alright, it's not within our syllabus, so we are not talking much about it. Okay, this yep, that will be about it. So look through carefully. Thank you.